Welcome, everyone. Thanks, everyone, for joining. I'm just going to give it probably a minute or so for more people to jump on, and then we'll go ahead and get started. As folks are joining, if you could put in the chat where you're tuning in from, and in the spirit of fall, your favorite fall activity you've done this year. Mine has been fall kayaking. This is the first year I've really done kayaking in the fall, and it's been beautiful.
I think just generally being outside with the way the weather's been this fall has been a pretty good activity in and of itself.
A lot of people are saying hiking, which I agree. Looking at trees and apples. I like that.
And eating
Great.
said apples.
Yes, right. That's the key step. Wow, a lot of hikers, folks from all over the state. That's fantastic. It looks like we have a pretty good number of folks on, so I think we should go ahead and get started, but feel free to keep putting stuff in the chat. Again, so welcome everyone. Thank you so much for joining us for our very last Weatherization Wednesday webinar. Today we are obviously talking about heat pumps because we know that once you weatherize your home, heat pumps are a really fantastic way to keep it warm in the winter and your home cool in the summer. So my name is Bekah Kuster. I'm a community engagement manager with Efficiency Vermont and joined by my fabulous colleagues, Bob Kogut and Steve Spatz, who are really the technical experts in leading today's presentation. But before I do turn it over to them, I'm just going to walk through a few logistics and intro slides, and then we'll kick off the content. So one, you might be noticing that we are recording today's webinar. So we're going to send that recording along with the presentation slides and chat resources to all registrants after the webinar, so you can expect an email from us. And then if you are interested in any of the recordings from past webinars, those will also be available afterwards as well. So getting right into it, we wanted to introduce who Efficiency Vermont is. We are the statewide energy efficiency utility, which means that we really help reduce the cost of energy for all Vermonters and really help folks understand and make better use of energy and reduce greenhouse gases. And we do this in a lot of ways, many of which we'll talk about in today's presentation. But one of those ways is education, which is why we are here giving today's webinar. We also help to facilitate and sponsor the Button Up Vermont campaign, which is Vermont's annual campaign to help Vermonters prepare for winter. This is really a campaign that's made possible by a really statewide collaboration of so many different partners. So that includes utilities, community action agencies, town energy committees, so many folks that come together each year to make this campaign possible. If you are interested in learning more about Button Up Vermont and all the resources that are available, there is a great website, buttonupvermont.org, that you can visit. And again, that's also where you can find all the recordings and information from previous Weatherization Wednesdays as well. And finally, we are doing a gift card raffle. So one lucky attendee from today's webinar will be randomly selected to win a $50 gift card to a local hardware store. We'll do that drawing after the webinar, but if you're that lucky winner, you can expect an email from us. And lastly, before I turn it over to Bob to kick us off, I'll just note, if you have questions, please feel free to put them in the chat immediately. We have some of my colleagues in the chat who are going to be able to help answer those questions along the way so we can really get to as many as possible. Hopefully at the end, we'll have about 10 minutes for Q&A. I'm going to start that portion by going back to some of the questions that we got in through registration, and then we'll do our best to address any remaining questions in the chat. But again, feel free to put those immediately in the chat as they come up. And lastly, we know that a lot of folks have very specific questions about their homes in regards to if heat pumps will work for them. And while we'd love to be able to answer those questions in a forum like this webinar, it's really challenging to do that. Steve is going to talk about some of the ways where you can get more one-on-one advice from an energy expert, because oftentimes it requires us to kind of learn a little bit more about your specific home and situation, and it's hard to do that in a webinar. So I'm going to ask that people hold off on asking very specific questions to their homes, but know that we have a lot of resources to support you and can connect you one-on-one with an energy expert afterwards. So with that, I'm going to turn it over to you, Bob.
Thanks, Bekah. Hi. So my name is Bob Kogut. I'm an engineering manager with VEIC and Efficiency Vermont. And I'm going to start kind of with the technical content, and then Steve's going to kind of pick up halfway through. So yeah, again, as Bekah said, any questions, put them in the chat, and There's a few people hiding behind the scenes to help answer them, and then Steve and I will help answer as well when we can. So, okay, here's my first slide. So what we're going to cover, Steve and I here, are going to cover kind of just the basics of heating systems, like what are the common ones in Vermont used in homes, and then describe kind of and give a kind of a basic understanding of what a heat pump is and how they work. And then talk to you about the different kinds of heat pumps that are used in residences. There are 4 basically to jump ahead. And then, how do you get started? So what are your next steps? What should you talk to your contractor about? Where do you get more information? So a good place to start is to kind of just ask yourself some questions about what do you want from a heat pump? And what are your goals for that for using heat pump? What do you want it to do for you? So those questions might be, I want to reduce my energy expenditure. It might be, I want my home to be more comfortable. Goals might be, I want to be able to cool it in the winter during the summer on the hottest days. You starting with your goals is a good place to start. And then the next thing to think about is, what do you currently have in your house? What's your current heating system? What's your current cooling system? What's your distribution system? That means, like, do you have ducts? Do you have, radiators, in-floor kind of distribution system? And then what's your budget? Those are probably the best places to start, the first things to start thinking about. So just like a quick overview of a traditional heating systems in homes. Generally, they burn stuff to create heat and distribute that heat through your home. So we're looking at a couple of furnaces here in basements. Common ones in Vermont are oil burning furnaces, propane furnaces, and in some areas of the state, more Chittenden County, natural gas burning furnaces. And then also, probably in a later slide, wood burning. So pellet stoves, traditional wood stoves as well are traditional heating systems. All of them burn something to create heat. And so different types, just another slide here looking at them. Usually, so boilers is one type. So that's a furnace that heats water, distribute the water through your house, and the water is in radiators. It could be an in-floor heating. Those systems require the furnace to burn the fuel to create the heat, pumps to kind of move the fluid around through the house, valves to kind of control where it goes. And then the last part that you see in your living spaces is the radiators, which could be, there's a lot of different types of them. Baseboard ones are very common. Sometimes boilers for your heating system can also provide the hot water for your domestic hot water supply. Okay, look at the next slide here. So furnaces. Again, I've said this a few times. Furnaces, they burn a fuel, and well, I guess this slide, sorry, is about more of a forced hot air system. So the last slide was about boilers, where your furnace is heating up water that gets distributed through radiators. Other very common system, the one I had in my house before I switched to heat pumps, was a forced hot air system. So there's a furnace somewhere in my house. It was in the basement. Mine was propane, burns propane, creates a lot of heat. And then there are a series of ducts through the house. And there's a blower system, which is called an air handler. Filters are involved in that system to kind of filter the dust out of the air. And then what they call the things that, the thing at the bottom of the picture here is a register, a grill, or a diffuser, all names for where the hot air comes out in your house. Okay. Heating systems without distribution would be a wood stove, classic example in Vermont. That means there's no pipes to move warm water around throughout your house. There's no, obviously no ducting. They heat rooms well. Open floor plan houses can be heated pretty well without having a distribution system. Wood stoves, again, are common. Pellet stoves, things like Rinnai heaters, and electrical resistance heaters that you might use. Okay. So what are some of the characteristics of fuel-fired heating systems? they create high temperatures. Burning things creates a lot of heat. They do not provide cooling in any way. No furnace can provide cooling. And oftentimes the cost of the fuel that you're burning can vary a lot, and that's true for oil, propane. It's even true for cordwood. And then anything you burn creates carbon emissions and air pollution from burning that fuel. Okay. So what about heat pumps? How are they different? So heat pumps run on electricity. They don't burn anything, and they can also provide cooling. So a typical heating system in your house that we discussed earlier, the furnace things, you burn something to create the heat, and you spread that heat around your house. A heat pump moves heat from one place to another. So it's an interesting system. What it does is it has this it moves a special fluid called a refrigerant around through this continuous loop, and that refrigerant can be through the use of a compressor built into the system and what's called an expansion valve, which kind of drops the pressure. You can kind of pump heat into this fluid, out of this fluid through your house. So a heat pump typically always has two different radiators, which can be called a condenser or an evaporator. One of them's inside your house to either push the heat into your home or push the cool or create a cool surface in your home. And then the one outside is either gathering heat from the outside to bring inside, or it's expelling heat to the outside if you're cooling. One of the way a heat pump works is that they're reversible. So that's one of the magic parts of a heat pump is a series of valves in there that let the thing run essentially backwards. So let's see what we got for the next slide here. No, okay. So this last slide going back, this is showing heating. This is showing a I believe this is in cooling mode. Yeah, the cool side is on the right here inside your house. Switch the valves in the heat pump and you put it into heating mode, where instead your cool side is in the outside. That refrigerant is cooler than the outdoor air temperature. Modern heat pumps that you get nowadays can collect heat from the outdoor air, even if it's as cold as -20 Fahrenheit out there, and pull heat from that cold air, but they're still pulling heat from it, and move it inside your house. This is showing a couple pictures of what an outdoor unit looks like, kind of the graphics, and then the indoor unit. They come in different styles. I believe later we've got some pictures of actual ones, which should be more helpful. Point I made earlier, but reiterate it. Here's a picture of two outdoor units of a heat pump system. Like I said, they can provide heat into your house even when the temperatures are below zero, down to as low as -20 Fahrenheit. Okay, so there are 4 different types of heat pumps, which I'm going to cover the first 2, and Steve's going to jump in and cover the second 2. The first one is called a ductless heat pump, also called a mini split, which I'm sure many have heard that terminology. The other kind is a ducted system. We'll get into that. Steve's going to do air to water, and he's going to do ground source, also known as geothermal. So ductless. Here's a picture of a typical indoor unit. This is mounted high on a wall. This is providing heating or cooling inside your house. There are other options other than these kind of wall-mounted near the ceiling units, but those are quite common. All right, so I guess they can also be called one-to-one heat pumps. I haven't heard that a whole lot myself. Ductless and mini split are the most common terms. And they could be, in one-to-one. They always have an outdoor unit and they always have an indoor unit. It doesn't always have to be a one-to-one. So ductless heat pumps can have an outdoor unit and have multiple heads inside the house, where that refrigerant fluid is being kind of heated or cooled in that outdoor unit, and then it can get piped into the house and you could send it to a couple of different heads. There are some downsides to doing it that way, because if you have one outdoor unit powering 3 inside units, you have a big powerful outdoor unit And if you only need the heat on one of the inside ones, you might be kind of essentially oversized for that. But those are details we can get into later, maybe in details you can get into with your contractor about what's the most efficient setup. So outdoor units. So we talked about this before. Every heat pump has an outdoor unit, whether it's a mini split or a central system or not. And here's a couple other pictures of them. They are hardy things that could be outside in the weather. It can rain on them, snow on them, wind can blow on them. They're built to handle all that. These are shown mounted on these little stands to keep them up off the bottom. The only thing you don't want is to have them sit inside of a snowdrift. Other than that, they are quite robust. Okay, indoor units. Okay, I promised a couple options other than the unit on the left, and here's a couple of photos of what some indoor units can look like for a ductless system. So this kind of lower wall-mounted radiator type style on the upper right, and a ceiling-mounted system that is hidden between your rafters up there. Okay, ductless heat pumps. So a ductless heat. Oh wait, this is what we're already talking about. Okay, typically these are the least expensive. They are the easiest to install. They can be used in a lot of different ways. And oftentimes they're a good kind of entree into the heat pump world. You can get a single mini split, a single ductless heat pump in maybe the room you use most often in your house, maybe your living area, your largest living area. And they can be used to kind of supplement existing heating systems. You can also get multiple ones and heat a whole house with ductless heat pumps, depending on how you design the system and lay them out. Okay. This is true of all heat pumps, but we'll probably make this point a few times through this webinar, that you should first think about weatherization before improving or changing out your heating system. The better air sealed your house is, air sealing is very important, and the better insulated it is, the less you're going to have to spend on heating, no matter what your heating system is. And you'll be able to buy a smaller and cheaper heating system if you have an optimal home in terms of weatherization and air sealing. Okay. All right. So where do ductless heat pumps work well? Again, like all heat pumps, you're going to get the best performance if you do some weatherization first. That is almost always the best bang for your buck. Spend $1 to improve your home to reduce your energy costs. The most efficient way to spend your money is to start off with weatherization. Because ductless heat pumps don't have distribution, you don't have a duct system, you don't have fluid moving through radiators you can put in different places. They're best for kind of open layouts. Because if you got a house that's cut up into a lot of different rooms with walls in the way, you're not going to be able to move the heat from that one large room into those small rooms. Kind of like a wood stove, which I'm sure many people are aware of how that works in practice. And they are a great choice if you just want to add heating and cooling to a particular room. Like if you built a new rec room or something, it's a great choice to kind of extend your heating system to a place that maybe hasn't had it before in your house. Okay, ducted heat pumps. Here's a picture of an outdoor unit of a ducted heat pump system. The only difference between this picture and maybe some of the ones you saw before of outdoor units is this one looks a little bigger, which is generally the case. Generally, a ducted heat pump system is designed to be a central heating system for your whole house. So the outdoor unit will be a little larger in size to have greater capacity. It is exactly the same technology though as a mini duct. The same stuff is going on under the hood. Okay, so a ducted heat pump system, also called a central heat pump. And there are two kind of subtypes of that called the centrally ducted and the compact ducted. Details we don't need to get into in detail here. There's a couple of pictures. The one on the right, that is that's showing a fairly typical looking indoor unit of a ducted heat pump. That black thing in the middle is the heat pump unit itself, and then you can see that galvanized metal kind of ducting on the right, where the air handler unit is blowing the the warm air into that ducting or cool air. Okay, what we got here. Ducted heat pumps can sometimes take advantage of your existing ductwork, and they include air filters, so which most heating systems, forced hot air heat systems do, but it's a necessary part. And you can run ducting kind of anywhere in your house. So you can you can reach smaller rooms. You can maybe duct it up to different floors as well. What else we got? Typically, a centrally ducted heat pump system is more expensive than a ductless system. In many cases, you might have to improve your ducting, but you can kind of work with your contractor for that. And you have to have ducts. You can't have a ducted heat pump system without the ability to without the existing duct system in your house or the ability to add a duct system into your house. What else we got? So where do ducted heat pumps work well? One point here, we say homes with unfinished basements. And basically that's so that you have the space for the air handlers and the ductwork. A common way to do it is like many furnaces were. Like my house was at first it was an oil burning furnace, and then we switched to propane a while ago. It's in the basement. The ducting starts there and kind of goes throughout the house. The registers are all on the floors on my first floor, and that's where the heat goes. So I was kind of primed in my particular house to move to a ducted heat pump system. This we were saying here pairs well with more robust interior renovation. That's just because ducting is not small, and if you have to add the ducting or modify the ducting in your house, it's just something to consider about where can you do these runs. And have it look good and have it work well. Okay. All right. Yeah, we're going to switch over to Steve now. So we'll talk about air to water heat pumps.
All right, great. Thanks, Bob.
Sure.
And appreciate everyone's questions in the chat here so far. We'll continue to try to answer those as best as we can. And also, a lot of these are going to be kind of very site specific and project specific, house specific, need specific to get to some answers on these things. So, the technology, Bob did a good job of explaining how heat pumps work, the applications of them here in our climate. We're talking about ductless and ducted heat pumps. Those are the predominant types of equipment we're seeing installed in Vermont and the Northeast for heat pumps at this time. Ductless, the ductless mini splits being the biggest chunk of that equation. Although we are seeing a lot of these split outdoor heat pump units being installed into existing furnaces. So if you do have the distribution in the home, as Bob was mentioning, for a forced air system, you can benefit from including the benefit of the heat pump into that existing system, still have the fossil fuel equipment there to supplement the heat pump and get distributed cooling in the house as well. The ductless heat pumps provide that ability to do space heating around the house with the location of the heat pump and get the cooling out of it as well. But what I'm going to talk to you here about in the second half of this is some more whole house system heat pump equipment types and designs. So this is looking at integrating heat pumps as a whole house heating system, either into an existing distribution system in the house or building new or modifying a building to incorporate distribution to accommodate heat pumps. At the beginning of the slides, Bob made a good connection here of fossil fuel equipment being high temperature output heating equipment. The burning of carbon-based fuels creates a lot of heat energy, and therefore the type of distribution that is connected to that type of equipment is putting out hot air or hot water, so higher temperature water or air depending on the distribution type. Heat pumps are low temperature distribution equipment for the type of capacity of heat energy they can move. The distribution side of the equation of how that heat energy is going to move through the house needs to fit to the capability of the heat pump. So we have to look at what the capability of the distribution side of the equation is to adapt heat pumps as a whole house system. So, and Bob mentioned that as well there with the ducted side of the equation, where sometimes you may need to modify existing ductwork to get the full benefit out of utilizing a heat pump to heat the whole home. So air to water heat pumps are the same essential piece of outdoor equipment depending on the type, but the idea being is that you have the refrigerant coil and a fan coil moving air across the refrigerant outdoors that is either pulling heat energy out of the outdoor air for heating purposes or expelling that heat energy if it's connected to a system that can do cooling. And the difference with an air to water heat pump is that there's a heat exchange occurring, where with the ductless and the ducted heat pumps, the indoor piece of equipment, you're blowing air across the hot refrigerant coil and taking the heat energy out of that hot refrigerant coil and moving it through the house via air. An air to water heat pump is taking that heat energy that's in the refrigerant side of the system and transferring that heat energy into water. And then almost uniformly and typically that hot water that is created by the heat pump is stored in a thermal storage tank. And then that thermal storage tank is used to distribute that hot water throughout the house through a variety of different emitters, as we call them, or radiators or distribution types throughout the house. So essentially it can be thought of as a heat pump boiler, but we're connecting a lot of the times with an air to water system, we are connecting to a hot water heating distribution system in the house, but there's a lot of flexibility with air to water equipment that will allow it to be connected to different types of distribution within a building. So you can mix and match these things if you are building new or completely renovating a house, or you can connect into these types of existing distribution systems that are within a home. So air to water, because of that ability to draw from a thermal storage tank, you have the flexibility to either use hot water heating distribution in the house or forced air, or with some manufacturers connect to ductless heads as you would with the mini split. So again, this comes down to what's existing in the home. You know, moving that heat energy either through an existing forced air ducted distribution system that may or may not have the capability to meet the temperature of what the heat pump can do, or conversely with a hot water distribution system within a home. So this is something, if you are interested in taking this route, it does take quite a bit of design and some good data inputs from the contractor side of things to look at what the capabilities and capacities are within the existing house to integrate a heat pump air to water heat pump into the equation. If you're designing new, then you can quite easily design a distribution system specific to what the capabilities of the air to water heat pump are and really match everything appropriately to get to that full house outcome. So there's a variety of different heating emitter types that you can integrate with this low temperature distribution. You can have standard baseboard that's designed for low temperature water. You can have taller radiators that are kind of flat panel design that can be set in rooms. One of the typical applications and a great application for air to water equipment is radiant floors and radiant heating. Radiant heating with low temperature distribution, either with air to water heat pumps or with geothermal or a really well designed propane or gas heating system, you don't get really warm floors because the water temperature that's needed to heat the house can be quite low. So you'll notice the floors are not cold, but they're not going to be like warm to the touch as you would with a high temperature radiant floor system. But that just goes to show how efficient the heat pump equipment is at heating the house at lower temperature water. So you get higher efficiency by lowering that water temperature, and flexibility in the types of ways you can distribute that heat throughout the house. So air to water heat pumps, again, they look similar on the outside as you would with a ductless or ducted heat pump. Typically the piece of equipment outside is going to be just a little bit bigger and usually have 2 fan coils on them rather than 1. You're either moving that heat energy from the heat pump through glycol and water to the outside unit, or just the refrigerant loop from the outside to the inside. The simpler the system design, the less expensive it will be, the easier it is to maintain and service and to function. So these do not need to be complex systems, and frankly, the less complex they are, the more efficient the system will be, and easier, as I said, to service and maintain for the long term. And Bekah, I'm having an issue with trying to advance the slides. Nope,
Okay.
there we go.
Oh.
I just had to switch to on the screen. I got it back.
Great.
So to summarize, air-to-water heat pumps can be thought of as a whole house system. You're either, like, again, designing a distribution system from the ground up to accommodate what the potential of the heat pump is, or potentially retrofit an existing system to integrate a heat pump. You can size and design the system to be completely off of the heat pump, with some integrated electric resistance backup heat in this thermal storage tank, or you can pair an air-to-water heat pump with an existing boiler or a new boiler to back up the heat pump water heater or to get other functionality out of it. So there's a lot of flexibility in how you can size and design these systems. Technically, you could do this. You could use an air-to-water heat pump system to do your domestic hot water heating as well. So it all comes down to careful design, doing appropriate load calculations, and knowing what your capacities are in the house to integrate this type of equipment. But with that, as noted, it's not yet at the point with this equipment where the heating capacity of how hot the water it is that the equipment can create for them to be a quote unquote plug and play replacement to an existing oil or gas or propane boiler. Because of that fact, in existing buildings, oftentimes there are improvements and changes that would be necessary to the distribution equipment in the house in order for the air-to-water heat pump to really benefit for the outcome. With hydronic heating in the house, with baseboard radiators or wall radiators or radiant heat, that does not allow for the cooling benefit to be utilized with an air-to-water heat pump. You would need to put in some other type of like ductless wall head or forced air ducted system in order to benefit from cooling with an air-to-water heat pump. But again, there's highly flexible system equipment and system design. So all in all, you could utilize all of these things and incorporate all these things into a system with the right design. So I'm kind of reiterating some of these points already. Low temperature emitters that are already there. If you have radiant floors, oftentimes that can be a great retrofit application without changing anything. And it does benefit, you do benefit from the ability to be able to zone your heat throughout the house, which is not necessarily something you can do with a standard, typical, quote unquote, forced air heating system. And so now finally, we'll jump into ground source heat pumps. So ground source heat pumps have some similarities to what we're looking at with air-to-water. These are typically most always connected to whole house distribution systems, oftentimes forced air systems, but also geothermal can work well with low temperature water hydronic heating systems as well. The differential here with a ground source heat pump is that we're using the ground as the heat sink to be pulling heat energy from for the heating side of the equation and then expelling heat into for the cooling side of the equation. There's consistency in the earth for temperature and a consistent BTU load that can be drawn from or pushed to when you're using a ground source system. Whereas with an air source system, you're going to have variability in the outdoor air temperature, which affects the performance of the heat pump throughout the season. So you do have differentials using an air source heat pump of what the overall efficiency of the operation is, depending on the outdoor temperature. The lower the outdoor temperature, the lower the efficiency of the system goes. The higher the outdoor temperature, the higher the efficiency of the heat pump will be. A ground source heat pump is often a very consistent level of efficiency throughout the entire heating and cooling season. So these are the main thing you're investing in a geothermal heat pump system is that heat sink side of the equation. Rather than just having a piece of equipment out there moving air across the refrigerant coil with the ground source system, you have to find your way into the earth. So you have to either be drilling vertical wells that are going to have piping put through them to move water and glycol through to do the heat exchange, or you're going to be doing a horizontal trenching type system, or sometimes as well using a water source, a pond or a lake or a river. Most of what we see for ground source heat pump equipment or geothermal equipment in Vermont are vertically bored wells that are either open loop or closed loop. So we're utilizing the heat energy in the bedrock of our area, of our geology, as the source for, again, both extracting heat and dumping heat for the cooling side of the equation. These are low temperature systems. So again, we have consistency of temperature and consistency of performance throughout the season. The two typical well types are a closed loop and an open loop. A closed loop system is you're drilling the number of wells to a specified depth for the amount of capacity you need for the heating and cooling load of the house. So that's based on tons, how many tons of heating and cooling capacity you need. So the drilling and what will be drilled will be something that's not me. What just happened?
1 second, I have no idea.
Okay, well, while we move through some
Okay, we were on, let me go back to the slide. I guess it just stopped sharing all of us, or it's sharing, but let's see, we're on air to water. No, we're on geothermal, my bad.
There's the
Okay, here's this
open
one.
loop and closed loop well.
Can you see it now?
I'm not.
You're not seeing it. All right.
Bob, are
Bear
you
with me
seeing
1
it?
second.
Here we are.
Well, this is a different, hold on, I'm gonna switch.
Okay. Yeah, I see something now.
All right, how's that?
We're back.
That looks
All
good.
right, amazing.
All
No
right.
idea what happened, but there we go.
No problem. Small hiccup. So just quickly, I'll get through this. Closed loop is a closed system. You're drilling wells. You're putting plastic tubing down into those wells in a loop, in a series, depending on the number of wells. They're connected to the heat pump in a closed system charged with water and glycol, and you're moving that fluid through those wells to do the heat exchange. An open loop system is where you're actually pumping and pulling water from an aquifer down below the ground. You're moving that through the heat pump, and then the downside of the heat pump that's expelling the cool water in the heating mode, where you're extracting heat, taking the heat out of the water through the heat exchange of the heat pump, and then pushing the cool water back into the well, typically, or sometimes that water can just be dumped on the surface of the ground. So these are the two types of ground systems, ground loops that you'll see with a geothermal heat pump. Depending on the driller, depending on the contractor, and depending on the geology, either type of these are utilized here in Vermont. So as noted, you can get consistency of temperature in the ground. So these can operate with really high efficiencies when they're properly designed. I was out with one of our partner contractors on Friday in Townsend going through the startup of a geothermal system. And by way of adjusting the water flow through the system and some other parameters with the equipment, you can actually dial in what the efficiency of the equipment will be. So that piece of equipment and that system, as we commissioned it on Friday, had a coefficient of performance of 4 is the term used to efficiency for heat pumps. And the equivalent of that essentially is that's a 400% efficient heating system compared to like an electric assistance system. So that would be consistency throughout the heating season at that level of performance. A geothermal system, again, can be retrofit into potentially an existing hydronic heating system, but more often into a forced air system. So again, either type of distribution can be utilized with geothermal systems. They are expensive because you're investing in that heat sink. The big investment here is drilling the wells, grouting the wells, piping, and everything that it takes in order to do that. And you have to have the space to be able to do that. There's good support in the industry to design these systems and install them, and a lot of experienced drillers in the state that do geothermal wells as well as doing domestic water wells. So there's a lot of resources in the state to utilize if you are interested in geothermal. But again, it is the expensive route out of the heat pump options that we're talking about here. So buildings with high heating loads that have the right distribution can be a good fit for geothermal for an existing building. Again, you have to have the right site conditions and geology to make it work. And low temperature distribution, again, is still the crux of utilizing the best benefit with geothermal and for air to water. So to summarize here, of all the different types that we've talked about, we've got the ductless. So we're talking kind of space heater approach, decentralized. It's not distributed throughout the building. Straightforward installations at the lower end of the cost spectrum. But if you want to try to do your whole house with them, it does require multiple units in order to be able to get to that outcome. Ducted equipment can be both small scale distribution of ducted distribution off of a small air handler that's connected directly to the heat pump, or the heat pump can be connected to an existing furnace or air handler to be able to do that heating and cooling distribution throughout the whole house. So a little bit more complex and expensive than a ductless unit, but does yield towards the whole house approach. And then air to water and geothermal, looking at low temperature whole house heat pump systems where you're really aiming there to be utilizing the heat pump as your primary heating system for the whole house. And you get the same level of flexibility of comfort and consistency throughout the house with the distribution that you would get with the quote unquote typical fossil fuel heating equipment. So some resources about how to take this further and to explore what your options are for potentially utilizing a heat pump in your own home. Think about what you want to do with it. What's your primary interest in the heat pump? Do you want to shave some of your existing heating load from your existing fossil fuel system to the heat pump for both either cost savings or for other interests as well? That's something to consider. Are you trying to get some better heating, even heating in parts of the house that don't have good distribution to them from the existing system? Are you primarily interested in cooling and maybe you want to benefit from the heat pump a little bit when you can during the heating season? Or do you want to go whole hog and try to, utilize heat pumps to do all of your heating in the home? So a lot of variables that go into play about what's the right system or right approach to take for you. Considering what it means to be comfortable in your home and how a heat pump can benefit from that. If you've had a baseboard hot water heating system in your home forever and that's what you've gotten used to, and you install a heat pump, a ductless heat pump, realize that you're going to be getting that heating from air moving across you and across the room. So that's something to consider as well. It's a different way of delivering heat and comfort in the room. The layout of your home, the distribution of what's already in the home, and weatherization are all factors of what makes the best fit for equipment type for a heat pump into a building. It always is the best approach to take to make sure that you've done whatever is financially and reasonably possible to the home to lower the heating loads and cooling loads on the house. So investing in tightening up the house is always the best first step to take when considering changing out any type of heating system or incorporating cooling. Look at what you can do to make that piece of equipment you're going to add to the house work as best as it can and cost the least to operate as a result. So looking into your options for improving the building envelope is always a great place to start. Efficiency Vermont has our home performance contractor network of trained professionals that work in that space of weatherization that you can work with, and we recommend that you do. Efficiency Vermont also offers a virtual home energy visit where you can connect with one of our energy experts here who can connect with you virtually to talk through your home specifically, answer your questions, kind of give you an overview about what your opportunities are, and connect you with a list of recommendations and places to take your next steps with from the result of that visit. So you can sign up at efficiencyvermont.com for that service. On efficiencyvermont.com, we also have our Find a Pro tool. So this is the way to connect with our partner contractors in our Efficiency Excellence Network. So through that tool, you can search for a variety of different options of contractor or professional types, from weatherization, the heat pumps, to architects, designers, lighting professionals, electricians. So It's a great tool to look at. You can search based on your zip code as well, so you'll be able to pull up your local contractors for the interest that you have of what you want to look into for services. If you are going to be talking to a contractor about putting in a heat pump, get a sense from them what they do. Not every contractor will install all types of heat pumps. Some will install just specific types and specific manufacturers. So get a sense as to what their capabilities are. I think it's worth asking if they service and maintain heat pumps as well after installation. Some will, some won't. If the company does not do services beyond installing heat pumps for HVAC, you may want to look at networking with an energy auditor or home performance contractor who could look at your potentials for doing work on the building envelope. Any heat pump that's installed should have appropriate load calculations done to size that piece of equipment appropriately for the space and/or building. So that is something you can ask contractor as well, how and if they do that load calculation for the building. So those are just some considerations to take when talking to a contractor. Efficiency Vermont and our partner utilities have a lot of rebate and incentive offers on the table right now for heat pump equipment. Our ductless and ducted heat pumps that are sold in Vermont that are on our qualifying products list are sold with a point of sale discount at participating suppliers in the state. So when a heat pump's purchased through those suppliers, these rebate amounts that you're seeing here for ducted and ductless heat pumps are applied at point of sale. Depending on the utility, there are some other income qualifying incentives that you may be eligible for as well. So that information can all be found on our efficiencyvermont.com website. Go under rebates and incentives and click into these different categories. You can read all the details. Air to water and ground source heat pumps are a project level rebate process. So these are not point of sale discounts. These are actual rebate applications that are submitted to us on a project level basis, but some pretty good money on the table for that type of equipment as well. If you do work with one of our EEN partner contractors, they will be able to offer you and allow you to access what we have for a financial tool, the home energy loan. This is a low or no interest loan offer that's available through our partner lenders that you see here on this slide. So if you are interested in financing a heat pump installation or heat pump water heater installation, weatherization, those are all types of measures that can be financed under the home energy loan. And depending on your household income, you can finance that for down to 0% interest. So you do have to work with an EEN contractor to benefit from that offer, but definitely something to take into account. Another financing offer is working with a partner in our weatherization repayment assistance program, where you're able to finance the eligible measures on your utility bill for up to 15 years. So it does not require cost up front, but you can finance that work through a charge that will show up on your utility bill. We have some contractors that are participating in that program. If you're interested in that, you can reach out to us directly or to ask your contractor about it when you speak to them. So that wraps up our content here on heat pumps. I have been seeing some more things popping up on the chat as we've gone along, so we can open up to further questions at this point.
Yeah, great. Yeah, a lot of questions in the chat. I think a lot of them are being answered, but I'm happy to go back to those. We did get some questions coming in through registration, many of which have been answered just through the presentation, but I thought I would touch on a few of them. So a lot of folks asked about cleaning and maintenance of heat pumps, and I want to just note that we put a great resource in the chat. Phil, one of our colleagues, also shared that you should clean the filters on the indoor unit every 1 to 2 months and have the system professionally cleaned every couple of years. But curious, Bob or Steve, if you have anything to add about maintenance.
Yeah, I mean, well, somebody asked in the chat about can you do a DIY, and the most important maintenance that you do the most often is cleaning out those air filters, which you can do yourself. And clean the filters or replace the filters. And that every couple of year maintenance, you generally can't do yourself unless you're a refrigeration contractor. But the bulk of it is keeping those filters clean. You got anything to add to that, Steve?
Yeah, I think the filters on the indoor unit, which hopefully your contractor will show you where they are and how to clean them. But otherwise, it's going to be in the manual from the manufacturer. It's good if you get a ductless heat pump installed in your house. For the first year or so you're using it, check those filters every month or so, see how clean they are, how dirty they get, and then decide how often you need to clean them from there. The long-term, deeper cleaning maintenance really does come down to conditions in the home. If you have multiple pets, if you live on a dusty, dirt road and the windows are open often, it depends on what accumulates within the system. But there are services available to do those deeper cleanings that available in the state to take care of that on a couple year cycle. So, it's really just like any other type of heating or cooling appliance. Maintenance is required. Your oil or propane boiler or furnace needs service and maintenance every year or two, depending on the piece of equipment. It's just something that you bake into the fact of it being a part of your life. So as it is with those pieces of equipment, the same mindset should be there in regard to a heat pump.
Great, thanks. We have some questions about kind of operation, and there was a question in the chat that got answered, but one person asked, what is the most efficient way to run a heat pump all year? And another person kind of was asking about if they prefer outdoor air, is it okay for them to kind of turn the heat pump on occasionally when the temperatures get really high? This is for the summer, for example. So could you talk a little bit about kind of the operation and use of a heat pump?
Mm-hmm.
Yeah, I mean, you certainly can open your windows and maybe alternate or even do it at the same time as running your heat pump. I can tell you, like my heat pump for cooling in the summer, I think I turned it on 3 or 4 times. Just those, because I never used to have air conditioning, which I think is true of a lot of people in Vermont. And it's amazing. It knocks down, you feel it knock down the humidity first, and then kind of lowers the temperature. So yeah, so most of the time I keep my windows open. If it's too hot, if it's one of those terrible 90-degree days, then I run the heat pump for a couple of hours.
Yeah. There's no right or wrong way to use a heat pump. It really is what you want to use it for, and so there's a variety of different considerations to take into account in running the heat pump. To get the most efficiency out of it, and to utilize it as your primary heat, during the heating season, the, common methodology there has been to set the control for the heat pump at a temperature that makes you feel comfortable in the room. Don't worry about whether it says 68 or 72 on the remote that goes with the heat pump. Just set it to a point where you feel comfortable in that space. And then have your thermostat for the primary heating system turned down so that the heat bat is not coming on while the heat pump is running. So that's the way to kind of just run it as a default for heating in a space if you're trying to, quote unquote, get the most out of it. But within that context, then too, you may want to choose to use your whole house heating system, for different times or different reasons for comfort. You may look at your electrical use compared to what you're paying in fuel and decide that you want to use one more versus the other. But again, there's no real right or wrong way to use it. It's just what you want to accomplish with that.
Right. I mean, you're not doing anything wrong if your old furnace happens to come on at the same time as your heat pump. It's just if you want to maximize your efficiency, running the heat pump first when you can run it makes a lot of sense. Running it in the shoulder seasons is especially efficient. So heat pumps are most efficient when they don't have to work quite as hard. We've said a bunch of times here that they can heat even when it's minus 20 outside, but they're really efficient if it's only 30 or 40 outside. And so a lot of people will do it that way. Run it the shoulder seasons when it gets really cold, then they'll allow their fossil fuel furnace to come on.
Great. We did have a few other questions about kind of the cooling component. So one person asked about the efficiency between a heat pump, and I'm assuming a ductless heat pump versus kind of using just a window AC unit. What might be most efficient?
More efficient, not because there's any magic. They do use the same technology. They're both run a refrigerant cycle, but generally window air conditioners, because they're the way they're mounted and the way they're installed, they're leaky and less efficient in that manner. So I mean, Steve probably knows better than this me, but practically as installed, the ductless heat pump is going to be a bit more efficient than running a wall unit.
Yeah, yeah. I
but
mean,
not like many times, not like, not wildly better, but better.
yeah. I mean, the refrigerant type is typically different than an air window unit of what's going
Yeah,
to be in a cold climate heat pump. And the overall capacity of a ductless heat pump is going to be better, and the ability to move that cool air throughout the space is going to be better than what a window unit would do. So there's a comfort opportunity and a electrical consumption savings opportunity with replacing a window unit with a ductless heat pump.
yeah. You don't have to take it out, in the winter,
Right.
which is a pain. Somebody else asked along the same lines, like, is there a difference in efficiency between a ductless system and a ducted, centrally ducted system? And the short answer is no. They both use, the kind of the same refrigerants, the same technology. They both are drawing air from the outside. So that's, yeah, they're generally the same thing, same efficiency. What is maybe can be more efficient is the water source or the geothermal ones, but then they're generally a lot more expensive to put in the first place.
Yeah. I mean, there is a caveat to that with the distribution side of the equation. The potential efficiency of the piece of equipment is one factor here, but how efficient it is at actually creating comfort in the space through how it's distributing that heat energy through the building can be a bigger factor. So that can have the bigger impact on the long-term operational expense and cost of using that piece of equipment. You know, factoring in what the efficiency of the system is doing itself too.
Complicated.
That's helpful, thanks. One other kind of question around like cooling or is around dehumidification. Someone asks they have a moisture issue in their home. It's too humid in the summer. Would a heat pump help with that? So is there any dehumidification?
They
That's a lot.
dehumidify. Not as much as a dedicated dehumidifier. I mean, well, actually, I'm going to back that up. I'm sorry, but think about heat pump hot water heaters. A heat pump hot water heater is essentially heat pump. Those do dehumidify a little bit. Certainly, a ductless mini split or a centrally ducted heat pump also dehumidifies. Yeah, so maybe it's enough for you. I can tell you, again, going back to my house as an example, which has a leaky basement that I'm still trying to contend with. I do have to run a dehumidifier in addition to running my heat pump some of the time in the summer to dehumidify. So, yeah, it depends on your particular situation.
Yeah,
See?
I think it does. It depends on the particular situation, and then if you do have high humidity issues with a home, it is always, again, good to look at what's the root cause of those issues with humidity. And oftentimes those are building envelope issues. If you have a really leaky home, it'll be cold in the winter because you have a lot of cold air moving through the house. But in the summer as well, if you have that house closed up, trying to air condition it, and there's a lot of warm, humid air leaking into the building, that can raise your relative humidity. If you have a lot of exposed, uninsulated concrete in your home, you have like a split level ranch where you have a finished basement and the foundation, unfinished basement, the basement foundation walls are not insulated, that you'll never overcome the humidity being generated and the condensation being generated by those conditions with a heat pump or even running a dehumidifier sometimes. So it's always good to look at the root cause. And then the benefit of utilizing a heat pump for dehumidification, again, is going to be coming down to how you use it and how often you run it. If you close up your house, you have multiple heat pumps in the house for cooling, and you run them all consistently, like, just let them do their thing, you can probably keep your humidity in check. But if you're using it intermittently, or just in one part of the house, it's not going to maybe have that holistic effect. But key is to always look at the root cause when possible.
Great. We only have a minute left, so I'm looking back through the chat, and it looks like Phil and Anna are answering most of those questions. But as a reminder, if your question was not answered, please do follow up with us. We put in our contact information there. And again, we will send around the recording as well as the slides and the chat. So all the resources and all the answers that were in the chat, we'll send to you afterwards. I think that's it. So thank you everyone so much for joining us. It's our last Weatherization Wednesday, but again, you can watch the recording of this and the previous Weatherization Wednesdays at the buttonupvermont.org website. Want to thank our panelists, presenters so much. Thank you, Steve and Bob, for lending your expertise and times today. With that, I say thanks everyone and have a great rest of your afternoon.
Yeah, thank you, everyone.
Thank you, everyone. Thanks, Bekah. Thanks, Steve.
Take care.
Thanks. Bye.